Welcome to Sandia Aerospace's online training course for the STX-165 Transponder system. This course will provide general information on the installation, configuration, and calibration of the STX-165 and STX-165R transponders. Please refer to the STX-165 installation manual for additional information when installing the equipment in an aircraft. The STX-165 is a self-contained, panel-mounted Mode C transponder with a built-in 35,000-foot altitude encoder. The built-in encoder provides altitude data for Mode C altitude reporting and outputs the altitude data on an RS-232 data bus or in a gray code format for interface to other avionics systems. The panel-mounted STX-165 can be paired with an optional STP-78 OAT probe. When the OAT probe is connected to the transponder, outside air temperature can be displayed along with density altitude and even an icing alert. The STX-165 transponder is also offered in a remote mount version. This model is the STX-165R. The 165R does not include a built-in encoding altimeter, but can be paired with Sandia Aerospace's SAE 5-35 remote-mounted altitude encoder. The STX-165R provides all Mode A and Mode C transponder functionality and is intended to be interfaced to an integrated flight display system. Starting with the STX-165 panel-mounted version, this unit features a half 3 ATI standard panel cutout and is 7.34 inches long behind the instrument panel. It weighs only 1.3 pounds and consumes 21.2 watts of power. It can operate at voltage levels between 11 and 32 volts DC. The operating temperature is from -20 to +55 degrees C and has an altitude operating range from -1,000 to +35,000 feet. The 1090 MHz transmitter has a 200 watt nominal power output, and the 1030 MHz receiver sensitivity is a nominal -74 dBm at a 90% reply rate. As for the altitude encoder, the gray code format outputs altitude in 100-foot increments, while the RS-232 output is in 10-foot increments and can be set to either a 1200 or 9600 baud rate. Looking at the STX-165R remote mount specifications, the only difference is the power consumption. The 165R consumes only 5.2 watts of power, much less than its cousin, due to the absence of a display. The remote-mounted STX-165R does not have an RS-232 output for altitude. Instead, it can receive altitude in either an RS-232 or gray code format. Both the STX-165 and 165R feature two electrical connectors on the unit. Both are standard density subminiature D connectors, one being 9-pin and the other a 15-pin connector. Mating connectors and back shells are included in the installation kit for each unit. In the panel-mounted STX-165, the 9-pin connector is identified as J3 and holds the power, external ident, suppression, and RS-232 interfaces. The 15-pin connector is J2 and contains the altitude gray code output, an unswitched power output that can be used to power an external device, and the OAT interface. In the 165R remote mount version, the main difference is in the J2 connector, where the OAT interface is replaced with a remote on-off discrete input, a discrete line called transponder select, and a baud rate select line. The STX-165R transponder will turn on when power is applied, but can be turned off by applying a ground to the remote on-off discrete line for at least 3 seconds. Grounding the transponder select discrete line disables the STX-165R as the active transponder in a dual transponder installation. The baud rate select discrete line is used to set the RS-232 altitude input to either 1200 or 9600 bits per second. Although both transponders have two RS-232 interfaces, the panel-mounted STX-165 only uses one of these interfaces. The STX-165 outputs altitude information on one RS-232 interface, but does not use the second interface. The STX-165R does use both interfaces, It can receive altitude information on one RS-232 interface and uses the second RS-232 channel for interfacing with an integrated display system, which is how the external device controls the squawk code and mode selections. There is also a coaxial antenna connector on each unit. A mating connector for the coax connection is included in the installation kit. Use RG142 or 400 coax to the antenna. The STX-165 system uses a standard blade-style transponder antenna or a rod and ball type antenna, which is ordered separately. Given the 21.2 watt maximum power consumption, it is recommended the power input be connected to a 1 amp circuit breaker on the avionics bus for 28 volt systems, and if installed in a 14 volt aircraft, a 2 amp circuit breaker should be used. When using the available power output pin on the J2 connector, the additional load consumed by the external device must be factored into the computation for the total current draw of the STX-165 transponder and the circuit breaker size selection. Refer to the STX-165 installation manual for more detailed information about each input and This section of the training contains installation considerations that you should be aware of before beginning an installation of the STX-165 or STX-165R transponder systems. Starting with the STX-165 panel-mounted version. Although the STX-165 is designed to fit in a half 3 ATI standard instrument panel cutout, the unit can also be installed in a standard 3 ATI cutout using an adapter plate available from Sandia Aerospace. The transponder unit is attached to the instrument panel using 4 632 screws, which are not included in the installation kit. Be careful when selecting the length of the mounting screws. Mounting screws that extend into the bezel of the unit greater than 0.15 inches will damage the unit, so make sure the screw length is only the thickness of the instrument panel plus 0.15 inches maximum. To assist with cutting the instrument panel, Sandia Aerospace also offers a half 3 ATI panel punch. Contact technical support for guidance on the use of the panel punch. If installing the optional OAT probe, consider the following precautions. Avoid mounting the OAT probe in or near the propeller airstream, engine or heater exhaust, transmitter antennas, or on dark painted surfaces to avoid erroneous OAT readings. The OAT probe requires a 7/16 inch hole be drilled in the aircraft skin. Consider fabricating an appropriate doubler plate in accordance with accepted installation practices as outlined in AC 43.13-1B. Skin thickness, including doubler, should be a minimum of 50 thousandths and a maximum of 0.188 inches thick. The OAT probe itself is hardwired with a pigtail approximately 2 feet long. This pigtail can be cut shorter or extended as needed to reach the transponder. Care should be taken to keep the electrical connections away from areas that can accumulate water or chemicals. Here are some installation considerations for the remote-mounted STX-165R. This transponder can be mounted in an avionics bay or any area inside or outside the pressure vessel. The unit can be mounted in any orientation using the slots in the mounting tabs. An optional mounting tray can be used as well to allow easy removal and reinstallation. The tray is mounted using 3 pan head screws and features a lockdown tab for the rear of the unit while the front is held down using a thumbscrew style knob. When installing the panel-mounted STX-165 transponder, you will need to connect the static port to the aircraft static system. When plumbing the static port into the aircraft, be sure your connections are secure to avoid leakage. The tubing should have an inside diameter of 0.125 inches and should be secured using a hose clamp or tie wrap. After installation, a leak check is required in accordance with FAR 43 Appendix E. Extremely important, never operate the transponder in a transmit mode without the antenna connected. This will result in damage to the unit's transmitter. The best practice would be to avoid even powering the unit on without the antenna connected to ensure it is not inadvertently switched to a transmit mode by accident. The transponder antenna should be mounted vertically on the bottom of the aircraft. The antenna requires a ground plane with a radius of at least 4 inches. Similar to the OAT probe, a doubler may be needed to strengthen the skin of the aircraft. Before we go any further with the installation of the STX-165, let's take a look at the operation and user controls on the transponder. Since the STX-165R is controlled through one of many integrated flight display systems, we will only look at the panel-mounted STX-165. Here is a front view of the STX-165 transponder. Starting on the left, there is a push-button rotary knob that has 2 functions. The push-button portion of the knob is used to simply turn the transponder on and off. Note that the unit will turn on when power is applied to the unit, but this push button can be used to manually turn the unit off by holding the button for 3 seconds and a momentary press to turn the unit back on. This button has additional functions as well. One is an escape function which allows the user to back out of a programming mode. This push button is also used to start the counters with a momentary press, being careful not to hold the button for 3 seconds, which would turn the transponder off. The rotary portion of this knob is used to select the operating mode of the transponder: standby, on, and altitude. Standby prevents the transponder from replying to ATC interrogations. On allows replies, but with squawk code only, also referred to as Mode A. And altitude mode allows full replies with squawk code and enables altitude reporting, also referred to as Mode C. On the right-hand side of the unit, there is another push-button knob with a dual rotary function. The push-button portion of this knob is the Enter button. This is used to complete an editing function. The outer rotary knob is called the Select knob and is used to move the cursor or to scroll from page to page in the setup modes. This knob is spring-loaded to the center position. Rotating it left or right against the stop will move the cursor from one digit to the next while in the squawk code edit mode, and it also is used to toggle through the display options in the lower left corner of the display when not in the squawk code edit mode. The display selections are pressure altitude, density altitude, and outside air temperature. But note that density altitude and outside air temperature are only available if the optional OAT probe is installed. Without the OAT probe, pressure altitude will always be displayed. Next is the inner rotary knob, which is called the Data knob. This is used for editing or changing values. An example would be when you enter the squawk code edit mode, the squawk code digit is selected with the outer knob, but the digit itself is changed using the inner Data knob. This knob is also used to select between counter modes when not in the squawk code edit mode. In between the knobs are 2 push-button switches with a photocell in between them. The photocell automatically adjusts the display brightness based on the ambient light conditions. The push button on the left is the VFR button. This is used to conveniently select the default VFR code, such as 1200, which is used in the United States. This can be programmed to a different default VFR code, which you will learn how to do in the upcoming configuration and setup section of the training. Pressing the VFR button a second time after selecting the default VFR code will bring back the previous squawk code. One more feature of the VFR button is that the pilot can press and hold this button for 3 seconds to enlarge the squawk code display, making it easier to see and edit, especially in high sunlight conditions. The push button on the right is the ident button, which the pilot will use to trigger the ident reply to ATC. The ident function will remain active for 22.5 seconds, which is indicated with the letters ID to the left of the squawk code display. The installer will use this button, along with the rotary knob on the right, to enter the setup pages for configuring the STX-165 transponder. When power is applied to the unit, a startup screen will appear, which will show the Sandia Aerospace logo along with some other useful information. First is the unit version number, which matches the last 2 digits of the unit's part number. Next is the display software version, which is shown after the D. Then there is the main software version following the M. The current software version for the STX-165 can always be found on Sandia Aerospace's website. Following the startup page, the unit will show the normal operating screen. To the left of the squawk code is the current operating mode. The squawk code displayed at startup will be the last squawk code used prior to shutdown. The bottom of the display is where you will find indications for pressure, altitude, and elapsed flight time. The built-in encoder requires a warm-up time, so the pressure altitude indication may be dashed out. This is normal until the encoder warms up and becomes valid. The operating modes, standby, on, and altitude, are selected by rotating the knob on the left side of the unit. Selecting a squawk code is accomplished by using the dual concentric knob and push button on the right side of the unit. First, push the Enter button to enter the squawk code edit mode. The first digit will begin flashing. Rotate the data knob until the desired value is displayed. Rotating the select knob will move the cursor to the next digit, which can be edited by again rotating the data knob. Repeat these steps for each digit until the desired squawk code is shown, then press the Enter button to save the new code and exit the squawk code edit mode. When not in the squawk code edit mode, rotating the select knob cycles through the available displays in the lower left corner for altitude and temperature. If no OAT probe is connected, the only available function is pressure altitude. If an OAT probe is connected, additional displays for density altitude, outside air temperature, and icing alert temperature will be available. Also, when not in the squawk code edit mode, the data knob is used to select between the three available timer modes. These are EFT, or elapsed flight time, CNT up, or count up, and CNT down for count down. The EFT timer may start at power up, or the user can select a predefined AGL or above ground level altitude at which the EFT timer will start automatically. The count up timer will begin at 0 minutes 0 seconds and is started by pressing the mode button. The count down timer default is 1 minute, but can be programmed by first holding the mode button for 3 seconds until the time is flashing, then adjusting the time using the select and data knobs. Pressing the mode button again will exit the time edit mode. Once the desired countdown time has been selected, the timer is started using the mode button on the left. The STX-165 Transponder features several other user program functions. These remaining user setup options will be covered in the next section of the training. The panel-mounted STX-165 Transponder has two setup modes, one for the installer and another for the user. First, let's look at the user setup mode. To access this mode, apply power to the unit and make sure the operating mode is set to standby. Press and hold the ident button while rotating the select knob counterclockwise against its stop. Continue holding the ident button and hold the select knob against the stop for 3 seconds or until you see User Setup Mode displayed. Now press the Enter button. This will enter the user setup mode. Here, the pilot or operator can adjust settings like altitude units, temperature units, icing alert temperature, when the elapsed flight timer starts, automatic switching to altitude mode, minimum display brightness, and default VFR code. A separate page is available for each of these settings. Scrolling to each of these pages is accomplished by rotating the data knob. On the altitude unit page, the user can select feet or meters for altitude units. To change the selection, simply rotate the select knob against its stop and hold until you see the selection change. Typically, you will rotate the knob counterclockwise to move the selection down and clockwise to move the selection up. When finished, use the data knob to go to the next page. On the temperature unit page, the units for the OAT temperature display can be set to Fahrenheit or Celsius. Again, use the select knob to set the desired temperature units, then use the data knob to go on to the next page. The Icing Alert Temp page allows the user to select the temperature at which the Icing Alert icon is displayed on the transponder. The available range selection for Icing Alert Temp is 32 to 41 degrees Fahrenheit or 0 to 5 degrees Celsius. Editing a value is a little different than the editing function in the last two pages. First, press the Enter button to enter the edit mode. Then use the data knob to change the selection. Pressing the Enter button again selects the setting and backs out of the edit mode. This type of editing function works just like the transponder squawk code edit function in the normal operating mode. Once you have set the desired icing alert temperature value, use the data knob to go on to the next page. The EFT start page is used to select when the flight timer starts. The user can have the flight timer start as soon as the unit is turned on or at a specified altitude. The altitude selection is the differential altitude from where the unit was turned on as sensed by the internal altitude encoder. Just think of this as the AGL altitude, or the altitude above ground level. If the pilot wants the flight timer to start as soon as the transponder is turned on, simply set the altitude selection to 0 feet. Since this is a value, press the data knob to enter the edit mode, rotate the data knob to select the desired altitude, then press the data knob one more time to exit the edit mode. When finished, rotate the data knob to go to the next page. The Auto Mode C altitude page allows the user to select a specified altitude at which the transponder will automatically switch to Mode C reporting mode. This is done similar to the elapsed flight timer start setting. The pilot can select an AGL altitude at which the transponder will automatically switch to Mode C, or leave the altitude set to 0, which will enable Mode C operation as soon as the unit is turned on. An additional setting for this selection is that the pilot can turn the Auto Mode C off, which will result in the transponder staying in standby mode at power-up and never automatically switch to Mode C reporting. In this case, the pilot must select Mode C manually prior to takeoff. Again, use the data knob to enter the edit mode, make your selection, then exit the edit mode. When finished, rotate the data knob to go to the next page. On the minimum display brightness page, the user can select a minimum luminance level for the STX-165's display. The ambient light sensor in the bezel senses the lighting level in the flight deck and automatically adjusts the display brightness. This setting is used to establish a lower limit on the brightness level to avoid having the display going too dark in low light conditions. To adjust this value, press the data knob to enter the edit mode, rotate the data knob clockwise to increase the minimum brightness level, or counterclockwise to decrease the minimum brightness level. When finished, press the data knob to exit the edit mode. The last user setup page is default VFR code. In the United States, the standard VFR squawk code used by ATC is 1200, but in other areas of the world, other codes are sometimes used for VFR operations. This selection gives the pilot the freedom to select a different default VFR code based on the region the aircraft is typically operated in. Use the data knob in a similar manner to edit the default VFR code, but here you will also use the select knob to move from one digit to another and use the data knob to edit each digit. That's all the selections for the user configuration and setup. To exit the user setup mode, simply press the Mode button on the left. Next, we will look at the installer's setup pages. To get to the installer setup mode, you must first enter the user's setup mode. Just to recap how to do that, we turned the transponder on and ensured it was in standby mode. We then held the ident button while turning the select knob counterclockwise until it hits the stop. We continued to hold the ident button and hold the select knob against its stop for 3 seconds or until we saw user setup mode displayed. Then we pressed the enter button, which brought us into the user setup mode. Once in the user setup mode, you can enter the install setup mode in a similar manner. First, scroll all the way to the last page, which is the default VFR code page. Now we will again hold the ident button while we rotate the select knob, but instead of going counterclockwise, we are going to rotate clockwise until you feel a hard stop. Continue holding the ident button and hold the select knob against its stop for 3 seconds or until you see the pressure altitude trim page. This page is used for calibration, which we will get to later. For now, rotate the data knob clockwise 1 click to get to the OAT sensor page. This is where you will select whether or not an OAT probe is connected to the transponder. To change the setting, rotate the select knob clockwise to move the selection up or counterclockwise to move the selection down. With the correct setting selected, simply rotate the data knob to go to the next page. The next page is OAT correction. Generally, the OAT probe should not need any adjustment, but over time, the OAT sensor may drift. This temperature adjustment of the OAT probe is covered in more detail in the upcoming calibration section. The next page is for RS-232 baud rate selection. This setting selects the baud rate for the encoding altimeter output. The default setting is 9600, but can be set to 1200 to match the requirements of other equipment in the aircraft that use this output. Use the Select knob to make your selection, then rotate the Data knob to go to the next page. Next is the Max Reply Rate page. The TSO for transponder equipment requires a reply rate between 500 and 1200 PRF. The default for this setting is 1200, which is also the factory recommendation. This should only be changed in certain circumstances, such as when the transponder will be operated on a battery. Lowering the reply rate would conserve battery power. That completes the install setup and configuration. To exit the install setup mode, simply push the mode button once to return to the user setup mode, then push the mode button again to exit back to the normal operating mode. There are two calibration procedures for the STX-165 transponder: pressure altitude trim and OAT calibration. Pressure altitude trim is used to calibrate the internal encoding altimeter to the aircraft, and the OAT calibration is used to compensate for any drifting of the OAT sensor over time. Both are located in the Install Setup pages. Just to review how to get to the Install Setup mode, first enter the User Setup mode by holding the ident button and rotating the Select knob counterclockwise until it hits the hard stop. Continue holding the ident button and Select knob for 3 seconds until you see User Setup mode, then press the Enter button. In the User Setup mode, use the Data knob to scroll to the default VFR code page. Here you will again hold the ident button and rotate the Select knob clockwise until it hits the stop. Continue holding the ident button and Select knob for 3 seconds and you should see the pressure altitude trim page. The calibration procedure for pressure altitude requires a pitot-static test set be connected to the aircraft. Only the static system will be run up, but the best practice would be to connect both pitot and static to avoid damaging the airspeed indicator as a result of negative differential pressure. When you have the pitot-static test set connected and ready to use, set the primary flight altimeter to the standard reference 29.92. Apply vacuum pressure to the static system to reach 35,000 feet. On the STX-165, press the Enter button and the H or high trim value will begin flashing. Use the Data knob to adjust the trim correction value until the displayed altitude shows 35,000 plus or minus 30 feet. Note that the altitude display is unfiltered and is in 1-foot increments, so it is normal for the indication to have minor fluctuations. After making your adjustments, press Enter to save the value, then run the pitot-static test set down to minus 1,000 feet. Use the Select knob to highlight the L or low trim value and press the Enter button to edit. Use the Data knob to adjust the trim correction value until the displayed altitude shows minus 1,000 plus or minus 30 feet. Press the Enter button to save the value. That's all there is to calibrating the pressure altitude for the STX-165. The pressure altitude reading is now calibrated to the aircraft. While still in the Install Setup pages, rotate the Data knob clockwise 2 clicks to get to the OAT correction page. The OAT should not require calibration at installation. However, over time the sensor in the OAT probe can drift. If this happens, use the following procedures to calibrate the OAT temperature reading. Before beginning this procedure, you will need to obtain a known, stable temperature for the OAT probe. It is recommended that you place a calibrated temperature sensor next to the OAT probe to find the current ambient temperature. On the STX-165, you will find a temperature readout on the OAT correction page. Press the Enter button to edit this value. Rotate the Data knob to adjust the temperature correction value until the displayed temperature matches the reading on the calibrated temperature sensor you placed next to the OAT probe. When finished, simply press the Enter button to save. A very simple calibration procedure. Just remember to always use a calibrated temperature sensor for adjusting the STX-165's temperature readout. In this training, you have learned about the installation, configuration, and calibration of the STX-165 and STX-165R transponder systems. We've discussed the various mounting options for each transponder, as well as the required and optional electrical interfaces. We studied the installation considerations for each transponder, then went through the operation of each function of the panel-mounted STX-165. We also looked at each page in the user setup mode, and then finished up with the install setup pages, including how to calibrate the pressure altitude and OAT. If you have any questions regarding the installation or operation of the STX-165 or STX-165R transponder systems, please refer to the installation manual, user's guide, or contact Sandia Aerospace's technical support team.